You are muted.
Muted, you are muted. Unmute.
Sorry, sir. Good afternoon, everyone. I am Pooja Nag, a student here at Bengal College of Engineering and Technology, and I am honored to be a host for today's Faculty Development Program, organized by our Entrepreneurship Development Cell and Institute Innovation Cell. This event is a space for us to connect, learn, and grow as a community. To start, I warmly welcome all of you on behalf of our college and extend heartfelt thanks to all. I would like to introduce our session chair, Ms. Devashree Sarkar. We are grateful to have you guiding today's discussion. Moving to our sixth session on natural language processing, it's my pleasure to introduce our speaker, Dr. Sudeep Kumar Naskar, Associate Professor in Computer Science and Engineering at Jadavpur University, with expertise in NLP and computational linguistics. Dr. Naskar's work has earned him accolades and a reputation for innovation in the field. Please join me in welcoming Dr. Naskar. Over to you, sir.
Hi, hello everyone. Am I audible?
Yes, sir.
Okay. Good afternoon to everyone, and welcome to this uh, session on talk on natural language processing. I know that this morning you have had a talk on NLP for legal domain, but I will give a talk on the overall NLP area. Like it will be not focused on a particular topic, but after attending this talk, hopefully you'll have a very broad overview of what natural language processing is. What are the okay? I have not shared my screen. I think just let me check whether my screen is coming or not. Is my screen visible?
Yes, sir.
Okay. Okay. So in this talk, we will basically talk about what is natural language processing, what are the different challenges, what are the different tasks, the core and important tasks, and what are the different applications, and then I will talk about some uh, uh, more of some of the more advanced topics, but I will not go into the models because I thought that I mean if it NLP you are totally new to NLP, there is no point in discussing and going into very details of a particular topic. Okay, so without further ado, let us start. And I think should I switch off the video or is it okay? Maybe I will switch off the video so that the screen comes better. Okay, so first of all, what is natural language processing? Natural language processing is nothing but processing of natural language, because you know that computers do not understand natural languages. And first of all, what is a natural language? Natural languages are those which you speak in a daily basis for communication purpose. So what is like Bengali, Hindi, English, and all other languages, they are natural languages. So what is not a natural language? A good example will be like a programming language. Okay, so a programming language also is a language. It has a syntax, it has a grammar. You can interact with the computer with a programming language, but it is not a natural language. We humans do not use it for communication purpose. Okay. So, but then why do we need natural language processing? Because you have, say, for example, for C, C++, yeah, it's good to have just a compiler for C or C++. If you have a compiler for C, then you can write programs in C. The computer understands. But the thing is, natural languages are not like programming languages. Natural languages are full of ambiguities. Uh, can you think of any ambiguity in any instruction or statement in a programming language? The answer is no. Any instruction or any statement in a program has one and only one interpretation. But soon I will give you many examples in natural language where you will see that natural languages are full of ambiguities. So it is a very challenging task to deal with languages for computers. For humans, it might be very easy. Even an illiterate person who does not know the ABCD of a language, who has never gone to school, he or she can still speak in his mother tongue, okay, without any difficulty, and understands in his mother tongue. But it is not the case for computers. So when we talk about natural language processing, there are several stages of processing, and if you have a background in from computer science, you have studied compilers, and there you have seen lexical analysis, syntactic analysis, and semantic analysis. So it is also very much similar, because in compiler as well, you are dealing with language, but with programming language. But in case of natural language, we say that the lexical analysis is basically what we call as morphological analysis, because morphology is the standard term in linguistics. By the way, natural language processing is also also referred to as computational linguistics. Okay, in fact the highest impact journal in our field, the core journal in our field, is named Computational Linguistics. It's an ACM journal. Okay, it's an ACA journal, and the most prestigious journal in our field. Okay, and computational linguistics is also taught as a course in linguistics courses. But the only difference being in computational linguistics, the head word is linguistics. Okay, so the thrust is on linguistics. Okay, and then they talk about the computational approaches to linguistics. But in natural language processing, the head word is processing. Okay, so we talk in the when we talk NLP in our engineering faculties, or in like I teach NLP in both in UG and PG courses. So we take a very computational approach. Like the processing is our main purpose, not the linguistics. Okay, so because you might think that it requires the knowledge of the language. Without the knowledge of the language, you cannot do NLP. But that used to be the case when it was like in the earlier phase of NLP. Then they were doing like more rule-based natural language processing. They need to know a lot about the particular language that you are dealing with. But these days, most of the models are like data-driven models. They are we do not even need to know the language. I have when I was working as a postdoctoral researcher, I was working on machine translation. I also did my PhD on machine translation. I was developing machine translation systems for, you name it, the language, and I have worked on it without even understanding which particular language is it. If you just give me the data, I should be able to develop the machine translation systems. That should be the approach in data-driven approaches to NLP. Okay, without even understanding the intricacies of the language, or without even having the basic knowledge of the language. If you have the data, we should be able to build some tools or solutions for particular language. Okay. Now coming back okay, so first of all, I will show you, give many cases of like why is NLP difficult, what are the challenges in NLP, why language processing is so difficult, and then I will go into the core tasks and applications. Okay, so first of all, just like you have studied in compilers, lexical analysis, so here also we do morphological analysis or lexical analysis. So I mean, you have some idea about lexical analysis. So I will go into more about morphological. When I say about morphological analysis, then I will talk about what we exactly do in morphological analysis. But for now, you know that in lexical analysis, we basically deal with the tokens. Okay. So in lexical analysis, we will see some examples of lexical ambiguity. Similarly, for syntactic analysis, we will see some ambiguity with syntactic analysis or parsing, similarly with semantic analysis. Here are some examples. Like say morphology can be ambiguous, and you know that the word dryer, it could mean the machine which dries, like the washing machine. You have sometimes a dryer that comes with the washing machine. Okay, or dryer could also refer to the adjective. Okay, which means more dry. So this is an ambiguous. You cannot, you cannot tell the exact meaning of the word without seeing the context. Okay. Similarly, here are some examples in Bengali. If you do not understand Bengali, then you might not be able to understand. But all of this word, every of this word has at least two interpretation. Say, for example, chini. Okay, it could refer to sugar, or it could refer to I know. Okay, I know you. I'm talking chini. Okay. Similarly, all of these words, they have two interpretations, and according to that, I mean, basically they have two semantic interpretations, and according to that, they have two lexical analysis as well. Okay. Then words like sheep, sheep can be a noun or a verb. Okay. The English word round is a very ambiguous word in English. Round can be like an adjective, it could be an adverb, and a preposition, a verb, even a noun, I think. Okay. Words can also have multiple meanings. Say, for example, the word letter could mean chithi, or like a missive, or it could refer to an element of the alphabet. Okay. Similarly, bank could refer to the financial bank or the river bank. So how do we disambiguate in NLP when you do, I mean, how do we basically deal with it? The only thing that is available to you for doing the disambiguation is context. Okay, so we look at the context, and whatever disambiguation you will have to do, you will have to do it from the context. Say, for example, John kicked a ball. You know that ball has two meanings. A ball could mean a physical ball, like round-shaped ball, or it could refer to a like ball dance. Okay, so now you know that kick is a verb, okay, that requires a physical object. Okay, now the ball dance is not a physical object, so it must be referring to the physical ball, round-shaped ball. Okay. Now in the second sentence, the ball lasted until midnight. So last is a verb, which means that which basically requires an event as a subject. So in this case, the ball must be referring to the ball dance. Okay. But look at the third sentence. When you hold a ball, now here you cannot really disambiguate from this context, because even the word hold is ambiguous. Hold can mean you can physically hold something, or hold can also mean organizing something. You can hold a conference or a seminar. Okay. So if the so depending, so basically you need further context. Okay. So until you have further context, you cannot disambiguate both the word hold and the ball from this whatever context you have. Okay. Structural ambiguity. So structural ambiguity comes when you can associate multiple syntactic structures. So if you have started compilers, there you have started parsing. Okay, you have started top-down parsing or bottom-up parsing. So basically, given the grammar of a language and given a sentence, or in terms of like if you are thinking of compiler, so given a statement, you will have to produce the parse tree for that particular statement. Okay. So similarly, in case of NLP, given the grammar of a particular language, say for English, okay, and given an English sentence, you'll have to come up with the exact or the right or the correct parse tree for that particular sentence. Okay, but the thing is, since language is ambiguous, sometimes it often happens that you can associate multiple structures with a particular sentence. Okay, so for example, take the first one: flying planes can be dangerous. Here, if it means, the sentence is ambiguous in itself because it has two different meanings. It could mean that planes that are flying can be dangerous, okay, or it could mean the act of flying planes can be dangerous. Okay, so depending on which exact interpretation you take, it will have completely different perspectives. So if it means planes that are flying can be dangerous, then can be like be is the main verb. Okay, but if it means that the act of flying planes can be dangerous, then flying is the main verb. Okay. Similarly, visiting relatives can be boring. It could mean that relatives who visit your place, you find them boring, or it could mean that I don't like to visit relatives' places. Okay, that is also another interpretation. I find it boring that going to visit relatives' places. Okay, so again, depending on the exact interpretation, you will have two different, completely different parts to it. Look at the following two sentences. Time flies like an arrow and fruit flies like banana. Although these two sentences look very similar, okay, just like time has been replaced by fruit and an arrow has been replaced by banana, it has completely different parse trees and accordingly completely different interpretations. In the first one, Time is the subject, flies is the verb, okay, verb phrase, and like an arrow is the prepositional phrase, or like the I will talk about prepositional phrase. So maybe I can talk now. So a prepositional phrase, or PP, is a phrase in English that starts with a preposition. So whenever you so prepositional phrases mainly act as modifiers. So say for example, I said he went to school in the morning. So this in the morning to the school, they start with a preposition, so they are prepositional phrases, and they always modify something, either the subject or the object or the verb. Okay. So in the first one, like an arrow is a prepositional phrase that qualifies or modifies the act of flying. Okay, so it modifies the verb of flies. But in the next one, fruit flies, this whole thing is the subject, and like is the verb. Okay, so you can see, although these two sentences look very similar on the surface, they have very different word stress. Similarly, the boy saw the girl with the telescope. Perhaps you might not see any ambiguity in this, but here the question is again with the prepositional phrase with the telescope. So when you were building a parser, so every prepositional phrase must be attached to something, to a node in the tree. Okay, to a noun phrase or a verb phrase or even a noun. Okay, so you will have a small parts tree for with a telescope. Now, should you attach it with the girl or the boy, or it could even you could even attach the with the telescope with saw. Okay, so if the boy had the telescope, you will attach it with the boy. If the girl had the telescope, you will attach it with the girl. Okay, but if maybe the interpretation is that it does not matter who had the telescope. The act of seeing was done with the telescope. Okay, maybe there was a telescope in the park, and the boy saw the telescope. Boy saw the girl with the telescope. Okay, so in that case, you will attach with the telescope with the saw. Okay, so you can see, even for very simple sentences, you can have many different interpretations as far as syntactic analysis is concerned. You can have completely valid multiple parts trees for a particular sentence. Okay, so we'll have to deal with it. How we can resolve or disambiguate such cases. Semantic ambiguity. So basically semantic analysis refers to when we are doing when we are dealing with meanings of words. Okay, so the English, so the word semantic came from the Latin word same, which basically means the root or the meaning. Okay, so if you look at these two sentences, in both the sentences, the word bank and interest appears, but in completely different senses. Okay, so in the first one, both bank and interest, they refer to the like the financial bank and financial interest, whereas in the second one, it refers to the river bank, and the interest here refers to the general interest, not the financial interest. Okay, so how do we give a sentence with an ambiguous word? Ambiguous means which has multiple interpretations, multiple meanings. Okay, or polysemous words. So how do we disambiguate the exact meaning of the word from its context? Multi-word units are also a difficult phenomenon in when you are doing natural language processing. So multi-word units basically refers to when you have multiple consecutive tokens which act as a single token or like a unit. Okay. So say for example, John eats in on Sundays. So here eat in is a phrasal verb which basically means that it's at home, eating at home. Okay. In the second sentence, you have the exact same word sequence. It starts with the exact same word sequence. John eats in a restaurant on some weekdays. But here, it is not the case. So here, in a restaurant is the prepositional phrase. Okay. Similarly, for the next two examples, John fell for many and John fell for a lie. In both these sentences, you have fall for. Okay. Fall for is a multi-word expression in English. So again, which can have two different interpretations. In the first one, fall for means falling in love with someone, okay, and or with something, okay. Or in the second one, fall for basically means John was deceived by a lie, okay. Then idioms is another like a complicated phenomenon in language processing when you are doing language processing. So here idioms are basically a sequence of tokens consecutive tokens, not necessarily exactly consecutive, because sometimes you can have, I will give you give you some examples, like where you can have some word in between the idioms. Okay. So kick the bucket, if you do not know the meaning of kick the bucket, it means basically to die. Okay, so how do we know that kick the bucket means die? Because kicking or bucket has nothing to do with die. Similarly, let your hair down means to relax. So how do we first of all identify the idioms, and then secondly, once we have identified the idioms, how do we derive the meanings of such idioms? Co-reference resolution. So co-reference and anaphora, they are almost like used synonymously. So you know that in English, or not just in English, in language, pronouns do not have any existence of their own. They always refer to something. Okay. So if I say, like he went to the market and bought blah, blah, blah. So here he must be referring to a person, right? So even the words, I mean, all the pronouns that you can think of, like it, they, he, she, whatever it is. So it, I mean, each and every pronoun must refer to something, okay? Because pronouns do not have any existence of their own. Now, the thing is, if you want to do deeper natural language processing, like say, for example, question answering or summarization, this kind of task. So there you need to know, there you need to do document level analysis. So you say, for example, you have this, he won Nobel Prize in this particular year, say 1901. Okay, so now the question is, I mean, person X, Y, Z, or in which particular year he won Nobel Prize. Okay, so now in this particular sentence, you do not have the name of that particular person. Now you will have to first establish that this he is referring to that person. Okay, then only you can be sure that that person has. I mean, you can generate the answer. Okay. Now, if you look at these two examples, I'll give you a second to read the two sentences. So here, the sentences, these two sentences are exactly the same, except that they have only one difference, the last word, failed and missed. Okay, everything else is the same. Okay, so here the question is, in the first sentence, of them refers to what? Them refers to some of the people, okay, from the crowd. And in the second sentence, missed, I mean, when you have the sentence, some of them missed, then them is referring to some of the bullets of the fire. Okay, similarly, you can think of another very similar sentence where them refers to some from the police. Okay, so you can see, so the sentence is almost similar. You have 10 or more than 10 words, only one word difference. So for that, the the pronoun is referring to some different entity. So how do you know this? How do you, as a person, I mean, you know, you can easily, because you know, the thing is, I'll go back to this example of yeah. So I'll start. Even the very term natural language processing is ambiguous. Do you see any ambiguity in this? Perhaps you have never noticed this ambiguity in natural language processing, because natural language processing, basically the meaning that we make up is that natural language, okay, and then processing of natural language. But in most of the times, when you have such noun compounds, okay, say for example, artificial neural network, we make the interpretation that neural network, which is artificial, okay, is a artificial neural network. So in that way, we can also have another interpretation like language processing, which is natural, like as if the human language processing, the way we do language processing, it does not require any effort. So it is almost natural. It comes with just like our, I mean, we do not even know how our brain does how our human brains process language. Okay. So just like I said, that even an illiterate person who cannot even read 1, 2, 3, 4 or basic ABCD, I mean, in his or her language, he can speak and understand fluently in his language. Okay, so how does our human brain does that? Okay, so there is a field of science which is called the cognitive science, so which is supposed to answer these questions: how our human brain processes language or do different tasks, do different other tasks. But cognitive science is, as of now, is still at a very nascent stage. Okay, there is, I mean, we do not know much about our brains, how our brain works. Okay, so that is the challenge with with natural language processing. So, see, I mean, we humans are so intelligent that we do not even see the ambiguity in such terms. Okay, because given any ambiguity, we immediately know what is the exact interpretation of that particular sentence or a phrase. Okay, but it is not the case with computers. So whenever computer sees any ambiguities, when it sees that there are multiple interpretations or multiple options, so it has to decide which exact interpretation it should take. Okay. So let's say you are building a chatbot. Co-reference or anaphora resolution is a very, very important task if you are building like a chatbot or like a dialogue system. Say, for example, take this example. So here the user says, my sister has a friend called John, and the chatbot says, "Oh, really? Tell me more about him." Then the user says, she thinks he is so funny. Here, the chatbot must understand that this she refers to the sister of the user. Okay. This he refers to John, who is the friend of the sister of the user. So at every stage, the agent or the dialogue system or the chatbot must make these such inferences. Okay, otherwise it cannot proceed with the like the conversation. It cannot make up the meaning of what the user is saying. Okay, there is something called Winograd schema. I will not talk about much, but so the previous example that I gave is actually called a Winograd schema. So Professor Winograd from Stanford University, he said that this is the example of an Winograd schema. So you will be given a sentence in which only one word will change, and for that, the pronoun will refer to a different entity. Okay, so you'll have to build this system which can disambiguate or which can identify properly which which entity or what this pronoun is referring to for these both cases. Okay. Uh, so this is a very difficult task. I mean, anaphora resolution. So here are some more examples of ambiguity. Like he noticed the shaking hands. It could have two different interpretation. Maybe she was shaking hands with someone, or maybe her hands were shivering. Okay, maybe in cold or maybe in fear, whatever. Okay. Now say I like tennis. Do you see any ambiguity in this? There is ambiguity. The ambiguity is the question is, what do I like about tennis? Do I like to play tennis? Do I like to watch tennis? What? Okay, that thing is not mentioned here. So in language analysis, this phenomena is very common where when we tend to drop words. Okay, so it means that I like to play tennis. I should have said that I like to play tennis, but instead I just say I like tennis. Okay, so we sometimes drop a word or multiple words in a say for example, if I say the movie I watched last night was great. Okay, the actual sentence, I mean, this particular sentence would be difficult for a parser. The actual sentence should have been the movie that I watched last night. Okay, but we often drop that word that. This phenomenon is called ellipsis. If you look at the following two sentences, John is eager to please and John is easy to please. So they look very similar, only difference being the eager and easy. Okay. Otherwise, they look exactly the same. But in the first sentence, John is the subject. Okay. John likes to please others. But in the second one, it means that John is the object here. Okay. So it is easy to please John. This is the meaning of the sentence. Okay. The chicken is ready to eat. Do you see any ambiguity in this? Perhaps not, but perhaps you think that the chicken is ready to eat means the chicken dish is ready to be eaten. But in native English, in like UK or in Ireland, New Zealand, Australia, USA, they often say this thing. They often say like this: the chicken or the fish is ready to eat. Means the fish dish is ready to be eaten. But you can understand that chicken is a living being. Okay, it also has hunger. Okay, so it may be hungry and it may be ready for dinner or something. Okay, so it has two different interpretations. But the thing is again, like computer is not intelligent as you, and so that is why at every stage it will face these ambiguities, and you will have to disambiguate all these different ambiguities. Okay, look at the sentence: I made her duck. Do you see any ambiguity in this? Perhaps you can think of more than one interpretations, but these sentences actually have at least 5 interpretations. So it could mean I cooked a duck dish for her, the first one. Okay. Second one could mean that maybe she had a duck. I killed the duck and then made a dish out of it. That is the meaning. I made her duck. Okay. Maybe third one is made a plastic duck or maybe paper, like origami paper duck, and then give it to her. Okay, that is another interpretation. Another interpretation is I threw something, maybe paper or some small stone at her, and then she had to quickly lower her head. Okay, ducking. And the fifth one is maybe I am a magician and I waved my magic wand and turned her into a duck. Okay. So these are at least the 5 different interpretations that you can think of, that you can make from this particular sentence. Okay. Now, speech processing is also, it also comes under the umbrella of natural language processing, because speech processing is nothing different. There also you are dealing with language. Okay. And the thing is, language has 2 different modalities. One is text. You can write something, you can write a letter and send it to your friend, or to someone, or you can directly just say it to him or her, okay, via speech. Okay. So but the thing is, when you are dealing with text processing, typically when you say natural language processing, you are typically referred to text processing, as if you have to do is you have to do dealing with text. Okay. But in speech processing, here it is much more difficult than simple speech processing, because uh, why? Because if you think of doing NLP in English, there you'll have to deal with only 26 letters because the English alphabet has only 26 letters and some symbols and the digits. Okay, that's it. But think of, you are dealing with say for example, you are building an automatic speech recognition system. Okay, so there your speech is analog signal. Okay, or even it may be digital, but the thing is, a signal is like a continuous signal. It can be one of my PhD students is doing work on, his basically PhD topic is speech processing. But what we have found in this last few years is that speech processing is extremely difficult, and it also requires a lot of uh, computational infrastructure for doing speech processing. Speech is, say for example, take a sentence that has 10 words. Okay, it does not even take like so if you think of a sentence which has 10 words in English, on average, and every word in English is about 5 characters. Okay, so including the null character, you need uh, like 6 bytes, okay, for every character. So, and for the entire sentence, maybe you need 100 bytes. Okay, that's it. But in order to store that speech signal, the original speech signal may be very like maybe a very short file, like maybe 1 MB. Okay, but if you do picture extraction and those kind of things on that, then the file becomes enormous. This 1 MB file becomes maybe 100 MB file. Okay, so speech processing is very difficult. But the point I'm trying to make is, speech processing is also difficult because of the ambiguities in when we speak something instead of write something. Okay, so let's say I say uh, when I say I saw, or let's say she, okay, and then there are some words, that she could mean she, or it could mean SWC. Okay, there is a subtle difference in the pronunciation, but there are many words which are sound exactly the same. So then you'll have to again disambiguate which exact word I'm referring to. Say for example, take this example, I made her duck. Okay, now say for example, you are building a automatic speech recognition. So given a speech signal, you will have to transcribe the speech signal into text. Okay, that is the objective of speech recognition system. Now, if you have a look at few of the sentences on the left, you will find that all of them look very sound very similar to the original sentence. Particularly if you look at this two particular sentences on the left, which are highlighted in green. I made her duck. Okay, and the one original sentence on the right, they exactly sound the same and there is no difference whatsoever. Okay, so how do you know, how does the computer know that when I said I made her duck, I did not say I made her duck or I made her duck, I said this, I made her duck. Okay, but this is not such a difficult challenge in speech recognition, because given these three options, the language, your language model will tell that this sentence or this sequence of words is much more likely than this sequence of words. Okay, so if you use a good language model, it's not easy. I mean, it's not difficult to disambiguate between these all these different combinations. Here are some more examples of like ambiguity, extremely ambiguous sentences. And these sentences appeared in Wall Street Journal news headlines. Okay, because you know that you might have noticed sometimes that because newspaper headlines are very short, they tend to drop a lot of words, and sometimes they make it very cryptic. Okay, so for example, teacher strikes, idle kids. Okay, take this one. Now, what do you think of this? I know you cannot interact or respond to this session, but the thing is, I'm 100% sure that the only interpretation that is coming to your mind is that the teacher is striking the kids who are idle. Okay, that's the only interpretation that is coming to your mind. But think of that. Can that sentence come as a news headline in a newspaper like Wall Street Journal? Here, the news is referring to a strike. The teachers are on a strike, so no classes are being held. So that is why the kids are becoming idle. Okay. So think of the complexity of such sentences. So the most frequent interpretation that will come to your mind is not the exact interpretation that the sentence has. Okay. Similarly, red tape holds up new bridges. So here, I mean, there are two interpretations. So one is red tape, you know this bureaucratic red tapeism. And hold up basically means to delay something. Okay, so some new bridge is going to be built, but because of the bureaucratic delay, it is delaying the process. Okay, the construction of the new bridge. But it also can have the meaning that, as if you know, red tape or black tape that is used for construction purpose, like not for construction purpose. Particularly, you might have seen it with the electricians using it. Okay, but red tape also like is used for joining something. Okay, so as if the bridge is being built using red tape instead of nuts and bolts. Okay, that can also be another very valid interpretation. So you will have to deal with all such ambiguities. Some more examples of ambiguity. All prices, this in this particular sentence, every single word belongs to at least two part of speech. You know that in English there are 7 part of speech: noun, pronoun, adjective, verb, adjective, preposition, adverb, preposition, and conjunction. Okay, oil can be a noun or a verb. Price can be a noun or a verb. Rose can be a noun or a verb. Up can be a preposition on an adverb. Okay. So how does I mean building a part of speech tagger is a like a very important task for doing basic natural language processing. Particularly if you want to build a parser, the first stage is you will have to build a POS tagger that can assign the right part of speech tag to every word, and then you can do bottom up parsing. Okay. Can you think of any meaning for this particular sentence? This is a valid sentence. If you look at this picture, perhaps you can think of this interpretation of the sentence. So this a ship shipping ship is the main subject. Okay, a ship that ships ship. Okay, this ships is the main verb, and shipping ships also like the object. Okay. In this particular sentence, you have 1, 2, 3, 4, 5, 6, 7 instances of will. But this is also another valid interpretation. The only thing you'll have to do to make up the meaning of this sentence is that this one, consider this will, all the wills with capital W, think of them as different persons. Okay, maybe your name is Will. Okay, I'm talking to you. You are person A, person B, person C, and person D. Okay, so but as if I'm talking to you, Will. Your name is Will. Okay, Will person B, Will person C, person D's will. Now it makes sense, right? So this will is auxiliary verb. This will is like the act of writing a will, and then this will is the will as a noun. Okay, so even this sentence which looks like a crab sentence, it is a valid sentence in English. Similarly, this is a classic example in English. The entire sentence made up of 8 instances of buffalo. I am not going to explain. You can search in this in internet. But the entire sentence is made up of 3 different interpretations. The Buffalo State, in which New York is situated, okay, and buffalo referring to ox, okay, and buffalo also means to bully someone, okay. But here in this particular sentence, buffalo, there is an ellipsis. That buffalo, this is the main verb. There are actually 2 different verbs. This is the subordinate clause and this is the main clause. Main clause is buffalo. This is the main verb and buffalo. I mean, it does not make so much sense, but the thing is, according to the syntax and both semantics, it is a valid and meaningful sentence. Now, like I said, that context is all you have, and whatever disambiguation you will have to do, you will have to do it based on the context. So to give you some examples of, like, look at this right screen. So, Mehbooba Mufti wants JNK student arrested for celebrating Pakwin release. This is talking about talking about the particular incident that happened after India lost to Pakistan in the ICC T20 World Cup. I think maybe in 2022, or I don't remember the exact year, which year, maybe 2020. So when I was looking at the news, I do not watch TV. So the only source of news is to me is like phones or sometimes laptops. Okay. So I saw this part. I could only see this part. Mehbooba Mufti wants JKN students arrested for celebrating ... Okay. But so I could not see this released. Okay. I mean, if you think of this particular sentence, now think of this particular sentence. Okay. This sentence and the previous sentence. Okay. Just because of this word being there and not being there, you have a 180-degree difference in the meaning of the sentence. This sentence means that Mehbooba Mufti wants the students to be arrested for this particular incident. Okay. Whereas in this particular sentence, it means that Mehbooba Mufti wants the arrested students to be released. Okay. So just because of one word, adding one word, it makes a 180-degree turn in terms of meaning. Okay. I mean, at every stage you will have to face ambiguity. So even if you think of the simple word and if I give you, I mean, say for example, you are taking a course on natural language processing, and I give you an assignment that build a system or a software, like very simple, like a software that can disambiguate every instances of and. Basically, you know that and is a conjunction which, you say A and B. So like and in English acts like a binary operator which requires 2 operands, A and B. Okay. So you'll have to find out, given a English sentence in which the English word and appears, you'll have to basically find out A and B. What are the 2 different things that this particular and is conjuncting? Okay. So and can conjunct it can conjunct nouns, it can conjunct pronouns, it can conjunct adjectives, verbs, adverbs, even prepositions. Do I have example? Yeah, look at this. Commuter lines in and around Tokyo. Okay, so in this particular case, and in conjuncting the 2 different prepositions. Okay, similarly, it can conjunct 2 different noun phrases, verb phrases, 2 different subclauses, main clauses, even 2 different sentences, everything. Okay, so even building this very simple disambiguation system for and can become very complicated. Okay, it might require full parsing to understand what is the exact interpretation of this sentence. Why else is natural language processing difficult? There are many different other phenomena for which natural language processing is very difficult. Say, for example, one example is the use of non-standard English, particularly in the last few years with the rise of the social media. You'll have to deal with so much of non-standard English. So, for example, so proud. This English word so is not a valid English word, but perhaps the user wanted to give an emphasis on the word so. That is why he gave many O after the S. Okay. Then this you basically referring to you. Okay. This 2 is not even referring to the number. Here, these 2 basically refers to the preposition to. You taught us to never say no, never say never. Okay, so you'll have to deal with such non-standard English, and you'll have to use some kind of text normalization techniques so that you can bring all the things to the standard format. Okay, unless you can bring this to the English preposition to, your parser will not work. Your parser will fail. Okay. Similarly, you might think that even tokenization is trivial. You might think that tokenization is very simple. Just use commas if you see any either any space or any like a comma or those kind of comma or full stop, those kind of symbols, then you know that there is the end of a token. And typically, if you see a hyphen, you know that the preceding word and the following word they are like acting as a single token, like a multi-word unit. Okay, so if you take that, I mean, if you think that it is that simple, look at this particular one, the New York New Haven Railroad. If you think that this is a single token, then you are doing it wrong. Okay, and you know that tokenization is the first stage of processing in natural language processing. Okay, so if you cannot identify the tokens with 100% accuracy, then you cannot expect. I mean, because if there is something wrong in the tokenization, then you cannot expect to have a good. I mean, you cannot have. I mean, you cannot have a, even if you have a 100% correct POS tagger or parser, even though it is impossible to have 100% accuracy for any AI systems. Okay, let us assume that you have a 100% correct POS tagger. So that will not work because you have identified the tokens wrongly. Okay, so we cannot expect that the POS tagger will correct it. That is not the job of the POS tagger. POS tagger simply assigns a POS tag to the tokens. Okay, I already talked about idioms. Then neologisms basically means sometimes we come with new words. In fact, in every language is growing. They add vocabulary or new words to their vocabulary. Okay, so think of the word unfriend. Before Facebook came, before Facebook came into existence, there was not this word unfriend. Okay, retweet. Before Twitter came into being, there was no word in English called retweet, romance, remedy. There are many such examples of words that are even the word netizen. Okay, so all those words that are joined in the particular language. And how do I mean? So because you know that but in the very modern dictionaries and in the very comprehensive dictionaries, they do not have all these words. But when you give some text that has such words, you expect you expect the NLP system to deal with this word. So how do the systems deal with such words? How do they discover the meaning of such words that it has never seen? Okay, or that does not even exist in the dictionary. Then sometimes it requires world knowledge. So knowledge about the language is not good enough. Sometimes you need knowledge about the real world. Say, for example, Mary and Sue are sisters, and Mary and Sue are mothers. In the first one, you know that Mary and Sue are sisters of each other. So it basically means that Mary is the sister of Sue, and Sue is the sister of Mary. Okay, but in the second one, you know that mother relation is different. Okay, Mary here basically means both Mary and Sue are mothers. Mother, okay, sister and mother relations, like mother is a directional relation. Okay, so how do you know? You can only know such information from from your world knowledge. I'm sorry about the noise. I did not know this thing is going to happen. I'm giving this lecture from home. Anyways, so then named entities, tricky named entities, identifying named entities is a very basic and fundamental task in natural language processing. It is called named entity recognition. So first of all, you'll have to identify the named entities like the person name. It's basically the proper names, person name, organization name, location name. Okay. And then you'll have to say that this refers to a person. So this is a person name, this is a movie name, this is a book name, and so on. Okay. But if you think of English, in English, you might think it is easier. But if you go into languages like Bengali or Indian languages, it becomes even more difficult because in English, typically proper nouns start with capital letters, but not in always. Say, for example, iPhone starts with a small I. Okay. But in Bengali or Hindi, you do not have this capitalization Q. Okay, and very often our personal names, like the names that we have, they are valid dictionary words. So, for example, I have a colleague whose name is Kamal Sharkar. Okay, he's very good in machine learning, and he also does natural language processing. Now, say you are building a machine translation system from Bengali to English, and you have encountered this Kamal Sharkar in your sentence. Now, unless you know that this is a proper name and this is a person name, you might wrongly translate Kamal Sharkar to the Lotus government. Okay, but you are never supposed to translate the person names. Okay, so that is the main thing with named entities. Named entities should never be translated, and named entities also play a very crucial role in information extraction when you are doing question answering or summarization or even simply Google search, web search. Then the most emphasis is given on the named entities. Okay, so identifying and classifying the named entities is also again a very difficult task in natural language processing. Maybe I'll skip some of this so that I can make some progress. There are a few different applications of natural language processing. So one very big, broad domain of natural language processing is information retrieval and information extraction. Information retrieval is very very. I mean, the point I'm trying to make is information extraction is very broad, but information retrieval has a very specific meaning, which basically refers to opt-in to web search. Okay, like you when you was doing some search in Google, it can also be image search or music search, anything. But when you this kind of search is called information retrieval. Okay, but information extraction is a very broad umbrella under which there are many different applications. Okay, so for example, you can do text classification. You know, I hope you know. I can give separate lectures on each of these topics, but text categorization or text classification, I hope everybody understands it. So, given a predefined set of classes and given a new text document, you will have to identify which exact class from the predefined set of classes it belongs to. Okay, that's the task of text categorization. Text summarization, again, just like we as humans do human summarization, let's say I do not have much time, I give a paper to my students and I tell him to read the paper and summarize it to me in 5 minutes. Okay, I do not have time to go through the paper. So he reads the paper, he understands the paper, and then he comes up with his own interpretation and summarizes the paper to me in his own words. Okay, that's the task of text summarization. So you want to build a computer system which can take a document or a text as input and can then summarize it. Okay, sentiment analysis. Okay, maybe I have some dedicated slides for them, maybe one or two. So here I'm just mentioning the different topics. So sentiment analysis, again, you know. So sentiment analysis is nothing but text categorization. Again, in text categorization, you can have hundreds of different tasks depending on the exact classes that you have. Okay, so in sentiment analysis is typically a text classification task where you are supposed to identify the intention of the not the intention but the sentiment of the user towards something. Okay, so was it positive about something or negative about something or maybe neutral about something? Maybe a movie review, you'll have to identify whether the user was positive about the movie, negative about the movie, or maybe he was neutral, neither positive nor negative. Math word problems, I will give some examples again. So here the task is like, in the primary schools, you were taught such problems like Ram went to the market with 100 rupees. He bought a pen worth rupees 50. Then the shopkeeper gave him 20% discount. Then he bought maybe an apple which costed him 10 rupees. And maybe he bought something, or maybe he came by auto which costed him 10 rupees. So how much money Ram has now? Okay, so these are like very simple mathematical problems, but that are expressed in natural language. Okay, from the natural language, you'll have to understand the exact interpretations of those what is being said, and from them, you'll have to essentially come up with a mathematical equation. That's the once you have the mathematical equation, solving is, I mean, you are basically done. Okay, knowledge extraction in cognitive science, it does not exclusively tell us how we humans store or extract knowledge in our brain. I mean, how do we, first of all, how do we gather knowledge? Okay, we gather knowledge by reading books or reading things. By uh, watching things. Okay, but if you think of a blind person, the only mode of gathering, okay, he can gather some knowledge through touch, like the shape of things, the texture of things, and by smell. Okay, but most of the information he gathers is through listening, which is through language. Okay, maybe he or she can also read, so through the language. But so whenever you read something, you gather some knowledge. Okay, now how do you first of all extract the knowledge from the text, and then again how do you store your knowledge in the brain? Now, in the cognitive science world, we do not have a very clear idea about how our human brain stores knowledge. Okay, but in the computer world, it is thought that it is a very widely accepted concept that uh, a piece of knowledge is stored as relation entity 1, entity 2. Okay, these triplets. A piece of knowledge in knowledge base has three parts: a relation between two entities. Say, for example, capital of, okay, in Delhi, or say capital, not capital of India, Delhi. Okay, so it basically means that Delhi is the capital of India. Okay, so you must have visited Wikipedia pages. So whenever you visit a Wikipedia page, you will see on the top right side there is a box which is called the info box. Okay, say for example you are visiting Wikipedia page of Donald Trump. He has recently become the president of USA. So you want some information about him. So those info box are meant basically to give you a very quick information about that particular, I don't know, maybe some organization or institute or whatever it is. Okay. So in that info box, you will see something like, so some information like date of birth, or let's say DOB. Okay. Then something, let's say 1978, 12. I'm making it up. So it basically means that that person on which that particular Wikipedia page is, his date of birth is this. Okay. So it is a relation like DOB, person, some person, okay, person 1, and then this. Okay. So in the computer world, knowledge is stored as a triplet. Okay. And then it is stored in the knowledge base. But the thing is, how do we first of all extract such triplets or pieces of knowledge from the text? Okay. That's the task of knowledge extraction. Okay. And then once you have gathered some knowledge, I mean, we have extract some triplets, you can represent them as a knowledge graph or big knowledge graph. Okay. Where these entities, they refer to the nodes. Okay. This India and Delhi. And there is a edge between them, which is capital, which is a directed relation. Okay. And the relation is capital. Okay. There can be multiple relations between between a pair of nodes. Say, for example, it could be that Delhi is also situated in India. Okay. Delhi is the capital of India, and so on. Okay. Fact checking these days is a very big application of NLP because these days with the rise of social media, so much of lies and fake news are doing the rounds in the social media. So even these days you cannot trust all the newspapers. You have to do fact checking yourselves. Okay, even many because so much of information is coming in the web. Okay, even the newspaper houses, they do not. I mean, whenever they publish something, they do not have the time or the resources to do the fact checking themselves. So they rely the other sources and they publish the news. But maybe that news, the entire news is not fake, but the most important pieces of information might be fake. Okay. Some more other applications, machine translation. I am sure that you must have used machine translation systems sometime for translating some document that you do not understand in that particular language. Okay, like Google Translate or Bing Translate. So, I mean, the purpose of machine translation is basically to build the language gap. Okay, I mean, if you can build a machine translation system between every pair of language, then it does not matter if you do not know a particular language or not. You can access all the information that are written in that particular language. Question answering, again, given a piece of text, you will have to come up with a system or software that can answer any questions asked on that particular document or text. Okay. Now, question answering can be on two different types. One is on text or documents. that is called machine reading comprehension task, like the vocabulary task that you often have in many different what should I say, like interviews, or that can not in interviews but in exams. But it can also have question answering on structured data. And what do you mean by structured data? Like database or knowledge base. Okay, given a knowledge graph or knowledge base, you have to like say for example WikiDB. Wiki have a very large knowledge graph. Okay, there are actually two knowledge graph. One is called knowledge base. One is called WikiDB and the other is called DBpedia. Okay, but there are many other large knowledge graphs like Yahoo, Yandex, many large knowledge graphs, which are very useful. But the thing is, it is not so useful to query on this, because you know that you as a computer scientist know SQL and you know how to extract information from database. But think of a layman, like say you must belong to some academic institutions. Let's say your institute has a very large database of all the students, of all the employees. Now, the person who is handling that, I mean, so think of an HR executive who is answering to different queries to different guardians and students. Okay, so he has to very quickly access the information from the database, but he or she does not or cannot write SQL. Okay, but so here the task is, given a query in natural language, can you automatically generate the corresponding SQL? Okay, if you can do it, if you can automatically generate the SQL, then extraction is trivial. Okay, just fire the SQL and you will get the information. Okay, but here giving the natural language query, say for example, the query is the HR executive writes, give me the names of all the students who have not submitted their examination fees, or who are maybe who have not yet filled up their admission forms for this particular upcoming semester. Okay, so you'll have to take this natural language query and then generate the appropriate SQL, and then SQL can be automatically fired, and then that HR executive can automatically get the information. But because every person does not understand how to write SQL, writing SQL is a very difficult skill. Even students, they cannot write SQLs for very difficult queries. Okay, and then again, given a knowledge graph or knowledge base, that you can access that information using SparkQL. Okay, Spark knowledge base, because knowledge base has different structure from than a database. It also has a different language, which looks somewhat similar to SQL, but it has a different name and completely different syntax. Okay, text normalization or text preprocessing is a very basic task that you might think. Whenever you do some like be it text analysis or image processing or video processing or speech processing, whatever you are doing, or some data analysis, data science task, you first do some basic data preprocessing. Okay, you first clean the data, whatever. You do some filtering and then you do some normalization. Then you subject it to further the actual stages of processing. Okay, let's say like the examples that I gave, like you have to say question answering on social media posts, but because social media posts contain a lot of non-standard English or grammatical mistakes or even spelling mistakes. So first, what you do is, given the text, you first normalize it. You first run a spell checker and bring the words to the standard forms. Then only you can run the PPO stacker and switch the parsing and so on. Okay, but often, so basically we often see this as a like basic preprocessing. But if you, I'm forgetting the name of that company. Yes, Grammarly. You know, Grammarly is a billion-dollar business these days. So their main, what do they essentially do? They do spell checking and grammar checking. That's it. Okay. So they have made a full-fledged software out of this basic. What we consider basically as a text preprocessing technique or data preprocessing technique in natural language processing. Okay. Some more examples like plagiarism detection. So if you are from academic institutes and if you are into research, then you know that these days the UGC is very strict about plagiarism. So if you, every institute must submit a plagiarism check report if you are submitting a PhD thesis But even more than that, if you are found of guilt of, if you are found of having engaged in plagiarism, then UGC is taking steps of like suspending or whatever. So because these days so much of information is available to you, even in the last few years, you have come up with these large language models or generative models that can do a lot of things for you, like writing for you. Okay, so even these days, like plagiarism, when we talk about plagiarism checking, basically we are talking about like plagiarism detection in thesis or research papers. Okay, so it has a very large database of papers, and then it basically checks whether a part of your thesis, where you said a like a length, typically like a 12 or 10 or a 8. Okay, the whether 8 consecutive words in your text appears in any of the previous papers. Okay, and how much of your paper has such similarity. Typically it requires that you have a less than 10% plagiarism check score for your thesis or research papers. Okay, but essentially this is a text similarity task. The task is, given a pair of text, you'll have to return a similarity score between the two pairs of documents. Okay. Similarly, answer or essay grading. So think of this particularly during the COVID. Much of the education system went towards the e-learning, like online-based platforms. So here the task is, in the US or in Europe or even in Europe, the senior professors, they take the class, they set the question papers, but they do not they do not check the student answer scripts. Typically, they have some TS, teaching assignments, some master degree students or PhD students, or sometimes postdoctoral researchers. So they do the evaluation. Okay, so the task here is, so the thing is here, the professor sets the questions, and then he also writes the model answer. Like model answer is very short answer, but it is supposed to give you the summary of the answer or the crux of the answer. Okay, so for example, you have a 5 marks question, so maybe the professor can give like just like 5 lines of text. Okay, that is the main thing that should be there in the answer. Okay, uh, so you'll have to evaluate the student answer with regards to the model answer. That's the task. Okay, but it is very challenging because, say for example, the student answer has exactly the information that is there in the model answer. Okay, so the question here is, will you give him 100% marks for that particular question? So 5 out of 5. You should not, if there is some wrong information in the additional thing that that the student has written. Okay, so say for example, it's a data structure question. Okay, so maybe I will not go into examples, but that's a challenge. Okay, so whatever piece of information the student has written extra, you will have to evaluate that part. Okay, first of all, you have to find out the similarity between the model answer and the student answer, and then given the text available for that particular book, you'll have to find the whether the extra piece of information the student has written is valid or not, and how much it is valid. Okay, and based on that, you'll give some answer. Readability assessment and text simplification. So one of my students is working on like basically NLP for e-learning, or we are calling it. I don't know what is it, the exact term. Anyways, so basically all the tasks there are related to e-learning, like education. Okay, so there it becomes an important task to find out. Say for example, you were looking for for a for an essay on something for your cousin, who is only 10, maybe 12 years old. Okay, so he or she is in class 6. Okay, so you do not want you are looking for an essay on a particular topic, but not for any level of students. You are looking for a particular you are looking for an essay on that particular topic which is suitable for that class of that, like 6th standard. Okay, so identifying which reading material is suitable to which particular class, or even identifying from the student answer, identifying the student there, like basically identifying the student groups, like these should have students have the same level of quality, or even when text simplification. Say for example, you have found an essay which is suitable for like the let's say the college level students or university level students. Can you build a system that can take the text as input, which is suitable for UG or college level or university level students, and then it can simplify it for, let's say, class 8 to 10 level students? Okay, that's text simplification. Event extraction. So I mean, you read these newspapers, and then your brain automatically extract information about what is going on. Okay, what are the events that are happening? Okay, and what events is leading to what events? So can you build a system that can automatically do this, extract events and causality information from text? That's the task of event extraction and causality extraction. Natural language generation. Well, natural language generation is NLG. Well, so what we are talking about NLP, there is something called NLG, which is referred to natural language generation. There is also something called NLU, which is natural language understanding. So typically, when we are talking about natural language generation, we are talking about natural language processing. Here, text is the input, or the not necessarily text, but language modality input. Okay, think of, we are doing only text processing. So here, text is the input, and output is something. It could be classification, or it could be anything. Maybe it could be maybe you are doing text to speech synthesis. So given a piece of text, you will have to build a system that can generate the corresponding speech. Okay, basically dictation software. In NLG, the classic definition of NLG is that its input has to be non-textual. Okay, maybe I'll So if you again, this pyramid structure comes up again and again in natural language processing. So think of this as NLP. Okay, so this is your input text. Okay. Text, and this is NLG. Here, your input is something else, some numeric values or something, maybe an image or something. Okay, your output should be an text. Okay, so say for example, let's say you're considering like image captioning software. Okay, so given an image, it will give a automatic title or maybe a description of that image. Okay, so that's NLG, what you are doing. So the image processing part does not involve, I mean, it basically involves image processing and computer vision, but the text generation part, it involves natural language generation. And on top, you have NLU, which is referred to as natural language understanding. So NLU is nothing but very deep natural language processing. So let's say you are doing some question answering system or summarization system, particularly for question answering system, you'll have to do very deep level of NLP. Okay, so NLU is nothing but very deep level of NLP. Okay, but say for example, if you ask me whether machine translation is a NLP system, it involves both NLP because it takes input text as input, but because it is also generating text as output in a particular language, it also involves uh, NLG. Similarly, if you're doing summarization, it involves both NLP as well as NLG. Okay. Then you can have domain-specific NLP. Like today morning session, he gave a lecture on legal NLP. Okay, so when you are building softwares for a very specific domain, because I mean, a software, say for example, you have built a machine translation software, okay, for let's say news domain, okay, which is very suitable or which can do very well on this news domain. But it can that same software, machine translation software, will not work well on say copyrights, okay, or IPR documents or legal documents, because those domains are very different. Okay, in legal documents on IPR, you can have a single sentence which has more than 100 words. Okay, you haven't never thought of this, that the sentence can exceed 100 words. Okay, and very difficult vocabulary and very difficult sentence constructions. Okay, similarly, depending on the domain, one of my student who is going to submit his thesis is working on FinNLP. So basically, NLP in the financial domain. So depending on the domain, the task also changes. Okay, you can have a completely different task. Say, for example, we have a project in legal NLP where the task is bail identification. Okay, so here the thing is, given a particular case, you'll have to automatically classify whether the that particular case, the person should be granted bail or not, okay, and on which clause he should be granted bail, okay. So, and this particular task is applicable only for the legal NLP task. It has no other application. I mean, it has no use in other domains, okay. Similarly, you can have also multimodal processing, where if you give both text as well as speech, maybe as video as input, okay. Say you are doing a say for example you are doing speech recognition, okay, but you have you have built a speech recognition system which is doing very well on a particular language, let's say English, okay, but an audio may be corrupt or very old, okay. So on that you cannot expect the speech recognition system to do very well. But in that case, if you have the video, then you can provide the additional video information as the input, and from the lip reading it can access additional information, because sometimes it happens. So we can do lip reading, because sometimes you must have noticed that the cameraman during sports is focusing on the batsman. He cannot hear anything what the batsman is saying, but still from his lip reading you can understand a few words, okay, what he is saying in that particular context or during that particular time. So basically you are giving additional information in terms of data from different modality, okay. So you are giving data belonging to multiple modalities as input to your systems. So these are multimodal processing. Shantanu, are you there? How much time do I have? I will go that accordingly, because I have a lot of slides, but I'm seeing that I'm only on slide 26. So can anyone tell me how much time I have? Accordingly, I will go. Shantanu or anyone from the organization team? Anyways, let me go and again, text classification, like I already said, that depending on the exact task and the different setup predefined classes, you can have many different text classification, like assigning subject categories or genres or topics to text. Okay, spam detection is a very old text classification task. So given a mail, you will have to say whether this is a valid mail or a spam. Authorship identification. So given a text and given a setup like authors, you'll have to identify the exact author who wrote that particular text. Okay, age identification. Well, you might not be able to identify the exact age, but age group identification, like whether a particular text was written by a primary school student or a high school student or a college level going student or a university level student, and so on. Okay. Gender identification, you might think that identification of gender of the author is impossible from the text, okay, but researchers have shown that that is also possible. If you give them enough like training data, then it is also possible to identify the gender of the author from the text itself. Head speech identification, personality identification, even language identification. So there are many languages which are written in the same script. So given a text or maybe just a short sentence, you will have to identify automatically in which particular language it is written. Okay, sentiment analysis, I already said what it is. Speech processing, when you're going to speech, there are two main tasks. One is ASR. In automatic speech recognition, your input is a speech and your output is the corresponding text. It's supposed to be the corresponding text. And in speech synthesis, your input is in text. So it is basically a dictation software. So your input is text and your output is supposed to be the speech that reads out the text, maybe in a female voice, maybe in a female voice. Okay. But there are some additional tasks in speech processing, like speaker identification. But speaker identification has nothing to do with language. Speaker identification is typically considered a pattern recognition task. Okay. Speech diarization basically means speaker identification plus speech recognition. So maybe I give you a recording of a meeting, okay, some important meeting, and your task you'll have to build a software which can automatically transcribe the text. Not just that, you'll have to say that this was said by, I mean, this portion of the speech, I mean, was said by this particular person. So person A said this, then person B said this. So it's like those, theaters or scripts, like of theaters. So that is speech recognition. Then language identification, just like in text. So given a speech signal, you'll have to automatically identify the which particular language it is being spoken. Normalization of ASR. So normalization of ASR is, let's say I'm saying this sentence, let's say we have, I'd say four, let's say, I don't know exactly the number. Maybe say 200, no, not 200. It must be more than 400. 400 and 52 students in our department. Okay, so if you, I mean, if I say we have 450, 52 is will be written as 52 students. Okay, so I mean the ASR system will write like this, but typically you do not write it like this. Okay, so when you say 452, it basically means 452 students. Okay, so this is the like a pre-processing or post-processing step on ASR. Okay, so this is a very basic kind of post-processing, but this is also an important normalization of ASR output. And particularly disfluency identification, because when we say something, we often stutter. Sometimes I am going to say something, I utter a few words, and then I completely abandon that sentence and move to, I mean, say another sentence. Okay, so the ASR system has to identify that what I was going to say, I did not actually say that. Okay, so that part does not have any meaning, so that part should be dropped. Okay, so that is called disfluency detection, and it has a lot of applications in dialogue-based systems. So think of all the dialogue-based systems or chatbots that we have these days on many different sites, but they work on like text-based. Okay, so you have to type something. But what if we can have a dialogue-based system where I can easily speak, and it can also speak back to me in just, I mean, I do not have to type, and it saves me a lot of effort. Okay, because typing is not very easy in mobile devices in those short screens. Some basic text processing tasks or like pre-processing tasks is sentence segmentation. So given a piece of text, you'll have to first break it down into sentences. That is called segmentation. One, because most of the intermediate tasks like PS tag or parsing, dependency parsing, they work at the sentence level. Okay, so first of all, given a piece of text, you'll have to break it down into sentences. Then from the sentences, given a sentence, you'll have to break it down into tokens or words. Okay, then once you have done segmentation and tokenization, then you'll have to normalize the words or the tokens. Okay, like the spell checker thing. In the lexical analysis part, we typically do some kind of lemmatization or stemming. Lemmatization typically refers to, lemma basically refers to the dictionary head word. Okay, so if you have these words comes, coming, or came, you'll have to go to the dictionary entry for come, because in the dictionary there will be no word by the entry comes or coming or came. Okay, so that is the task of lemmatization. So I mean, think of an application where you are building a solution. Okay, you have a good dictionary, machine level dictionary that you can fill, but unless you can do lemmatization in your system, you cannot. Even that dictionary is of no use. Okay, so you'll have to automatically find that comes basically refers to the lemma come. So if I go to the entry of come, then I will get the definition of what it means. Similarly, morphological analysis, perhaps you will not understand this, but I will give you I mean, if you do not understand Bengali, then you will have to understand this. But take the English word unsuccessfully. Okay, so you'll have to identify the morphemes. Morpheme is the bits and pieces of words that make up the meaning of the word. Okay, so here the actual word is formed like this. Okay, so the root is this, root of the lemma or this success, and then this morphemes on basically, I mean, so when pool is added to success, it basically makes a word adjective. Okay, success is noun, Successful is adjective. Successfully is adverb. Okay, when on is added to successfully, it makes the negative sense. Okay, or you can also think like this. So successful, and then first you form the unsuccessful, and then ly is added, which gives the adverbial sense. Okay, there are two things, two types of morphology in morphological analysis. One is called inflectional morphology, and the other is called derivational morphology. In inflectional morphology, derivational. In inflectional morphology, say for example, come to coming. Both the words, I mean, you are forming a new word, okay, but it also belongs to the same part speech, okay. But if I say success to successful, okay, though, so you are making a new word which belongs to a different part of speech, or success to successful to successfully, okay, you are making new words which belong to different part of speech. So this is called derivational morphology. Then a POS tagging, so given a sentence, you'll have to assign exact part of speech tag, okay? And by these part of speech tags are often very fine-grained. So not just like saying this word is a noun, this word is a verb. You also saying this word is a, so this NNP, so there is a thing called Stanford POS tag set. So Stanford has a very, historically, they have a very strong NLP team and NLP presence in NLP. So the first big library came from Stanford Library. Okay, so they have come up with this POS tag set, which in which for English, it has 52 fine-grained POS tag set. So this NLP basically means proper noun. This verb VBT basically means verb in past tense. PRP means this is pronoun and possessive pronoun. Okay, possessive pronouns. We is a pronoun. Our is the possessive pronoun. Okay. NN means basic form, noun. This is determiner, noun, and so on. This RB is adverb. JJ is late. Later will be JJR, comparative degree. Okay? Latest is JJS, and so on. So you'll have to assign these POS tags. Then, given the same sentence, the task of the parser is to come up with the parse tree given the grammar of that particular language. Okay, so if you parse this particular sentence, it will look something like this. So in this particular sentence, the lip nodes will be the words. Okay, if you traverse the lip nodes from left to right, you will get back the original sentences, and you can also represent the parse tree like this bracketed structure. Okay. Now, how the parsers are developed? Parsers are developed. Well, typically, it is a supervised approach. So typically, what you need is we call a tree bank. So that is basically your training data, where you have a lot of. Let's say you are developing a parser for English. So you need a lot of English sentences already parsed. Okay, for which the parse tree is available. So that is called the tree banks. Okay. Now let's say your tree bank has only two different. I mean, only say let's say two examples. Okay, I mean, if you try to build a parser only of maybe even 100 sentences, it will not work. Okay, you need a lot of training data for that. At least a few thousand sentences. But let's see how it works. I mean, what is the approach? Okay, first of all, given the tree bank, you do not even need the grammar. You can automatically extract the grammar rules. Like these are the grammar rules that you have seen being used in these two parse trees. Okay, then you count their frequencies. So how many times you have seen each of these grammar rule being applied? So for example, S to NPVP, you have seen this example only twice. Okay, so you see their count. Okay, how many times each production rule or each rule has been applied. Okay, then you count their probabilities, or like you compute their probabilities. Let's say take this example. Let's say MP2 pronoun and NP2P NPPP both can be there. So given an NP, you can either have only a pronoun or a noun phrase followed by a prepositional phrase. Okay. Now, so these. Okay, which example? Let us take this. Okay, no. So this NP was seen to in total 7 times. Okay, NP 2, this 4, and 1. 7 times NP was seen. Okay. In fact, you can see here 1, 2, 3, 4, 5, 6, and 7. Okay. And out of that, this particular rule was applied only applied only once. This NP to PPPP, I don't know where it is. NP to NPPP, this parse tree, this subtree was seen only once. Okay, so the probability of this rule being applied is 1 over 7, which is whatever is the value. Okay, so at the end of this, we have come up with a probabilistic context-free grammar. So that is basically the approach that we take for building so given a tree bank, we first build the context-free grammar and the probabilistic context-free grammar, and then we apply a top-down approach to build a parser build a parser for an input sentence. Okay, there is something called dependency analysis, which comes somewhat in between syntactic analysis and semantic analysis. So let's say, let's go back to. So let's say, let's take a very easy, simple sentence. Ram ate rice. Okay, Ram ate rice. Ate rice. Okay, so you have already seen how the syntactic parse tree looks like. Okay, so in which the words are the leaves in the parse tree. But here, in case of dependency parse tree, it will be something like this. So every word is a node. Okay. So if you have 10 words in the particular sentence, the corresponding dependency parse tree will have 10 nodes, or I see. Okay, it is very difficult to use the mouse for writing. Anyways, so a dependency parsing is much more informative than a simple syntactic person. So it will say that this is the subject and this is the object. Okay, so every word is being represented here in the dependency parse tree as a node, and there are relations which are directed relations and labeled relations. So it is not just a edge, this is directed edge and labeled edge. Okay, so this is how the dependency parse tree will look like for the sentence, simple sentence Ram ate rice. Okay, now going back to our same example, JetBlue can the same sentence. Okay, so if you, I think this I used, I forgot which particular dependency parser I used for this, but these two sentences, these two parse trees are developed by two different parsers. But if you notice, these two parse trees are different. With one interpretation, this says that JetBlue canceled our flight this morning. Okay, so in his this late, look at this late. Okay, so here the interpretation is as if JetBlue canceled our flight this morning, which was already late. This which was already late, this late is connected to this. So it gives the interpretation that the cancellation was done very late. Okay, but in this particular case, you will see that late is connected to the flight and the flight was cancelled. Okay, so it gives the interpretation that JetBlue cancelled our flight and because the flight was already very late. Okay, that interpretation. So both the interpretations are true, but depending on the interpretation, you will have two different parse trees, dependency parse trees. In semantic analysis, I have already said that it deals with meanings of words. In semantic analysis, the first and core task is word sense disambiguation. This is the primary task in semantics. Okay, because words are ambiguous, words can have multiple meanings. Given an ambiguous word or polysemous word, you'll have to identify the exact meaning of that word in that particular context. Okay, then semantic similarity is the task of, like, given a pair of words, you'll have to assign you'll have to return a similarity score between the pair of words. Let's say between king and queen, you will give a very high similarity score, maybe 0.8 or something like that. Okay, maybe between football and baseball, you will give a you will give a score like 0.5 because they also have somewhat similar. Both are field games, both are outs, and so on. But between baseball and cricket, maybe you'll give a very high score like 0.75 or 0.8, something like that, because they have very similar kind of things. Okay, so now you can extend this word similarity approach to sentence similarity approach. Okay, so given to sentences, complete sentences, you'll have to assign a semantic similarity between them. If you extend that, then you will get text similarity. Given a pair of text, you'll have to assign a similarity score between that pair of text. Okay. Another task in semantic analysis, which is typically not covered in courses, like because it is a very difficult task, is called Watson's induction. So here you do not start with a dictionary. Okay, so in order to do Watson's disambiguation, you will have to have a dictionary, because it is essentially a classification task. So say for example, for a particular word, you have 3 meanings in the dictionary. Then and the dictionary is machine readable. So the computer has to decide which exact meaning I should take from these 3 meanings, out of these 3 meanings. Okay, but in this case, you do not have any dictionary at all. So you have to come up with your own dictionary or meanings of words. Or let's consider the case, because no dictionary in the world is exhaustive. Okay, so even if you take up a dictionary, very modern dictionary, you will not have this meaning of what is it? The tablet. Okay, tablet as a mobile device. You will not have that meaning in any of the dictionaries, even in very latest dictionaries. Okay, so how does a computer know? Can the computer detect that? So tablet has only one interpretation in that particular dictionary. Okay, but let's say the sentence is, I went to the mobile shop and bought a new tablet which has this specification and which cost me this, and so on. So computer reads the sentence, and as a human, you know that whenever I am saying this sentence, I'm not talking about the medical tablets, but I'm talking about the electronic device. Okay, but can the computer also make the same kind of induction that in this particular sentence, induction, the word tablet must have a different meaning, which is not, I do not know what the meaning is, but it must not be listed in the dictionary. Okay, it is outside, it is beyond the dictionary meanings. Okay, so that is called Watson induction. Basically, inducing the senses of the words. Okay, meanings of the words. So for Watson induction, or for we call it distributional semantics. It is also called a vector space models of meaning. So the idea is basically, I'll directly go to this example because I'm already running late. Does anybody know this particular word? I'm pretty sure you do not know this particular word. If you have not, if you're new to NLP, you have not never heard this word. This is going on, but this is a valid word. Okay. Now, a bottle of Tesquina is on the table. Now, what do you think? It must be some liquid, right? It might not be a drink. You're not sure yet, but it must be some liquid. Everybody likes Tesquina. Now it looks like a drink, a popular drink. Okay, Tesquina makes you drunk. Now you know that it is an alcoholic drink. Okay, we make Tesquina out of corn, so you know that it is some kind of a, I don't know what exact drinks are made out of corn, but you just a minute ago you did not have any idea about the word Tesquina, but just by looking at these 4 sentences, you now have a pretty good idea about what this word means. Okay, so how did he make up the meaning of the words? By looking at its context. Okay, in which context it appears. Okay, so that is also the notion of distributional semantics or distributional meaning. Okay, so we look at the context and we come up with the meaning of the words. Okay, so in distributional semantics, we use something called term context matrix. First of all, what we need is a very large corpus for that particular language. The larger the better, okay, because you typically cannot build such a model on a very small corpus. It will simply not work. First of all, if it is a very large corpus, if it is not a very large corpus, then your model will not be exhaustive. It should see all the words in that particular language, and then it should see every word many times. Okay, now this thing is called term context matrix, which is a concept I've borrowed from information retrieval, in which we have something called term document matrix. But in term context matrix, it is a symmetric matrix. First of all, if in your corpus, if you have, let's say, 1 million words, so that is your vocabulary size. Vocabulary is the set of unique words that you have seen in your corpus. So these term context matrix is quite a big matrix. So it has 1 million rows and 1 million columns. Okay, each row represents a term that appears in the corpus, and each blue word, which refers to each columns, refers to a context word. So these 6 here basically means that data was seen 6 times in the context of information, and by context we typically define a context of, let's say, plus minus 5 words or plus minus 10 words. Plus minus 5 words means look at 5 words to the right and look 5 words to the left. What are the context words that has appeared within the context? Okay, and this is how we build this term context matrix. And once you build the term context matrix, then you can think of the entire row as we call this term vector. Okay, term vector. I mean, we do some more processings, not just the raw counts, but this is how it is scientifically. Okay, so if you look at the term vectors for apricot and pineapple, you can see that they have. I mean, this is not the entire. So this is like just a small snapshot of the term context matrix. But you can see that they have a pretty similar term context matrix. So if just by taking the cosine similarity or some other similarity, you know that apricot and pineapple, they have pretty high similarity score. Okay. Similarly, if you take the example of digital and information, they also have pretty like same looking vectors. Okay. So here the similarity between apricot and pineapple is higher. The similarity between digital and information also looks quite high. Okay. But if you take the similarity between information and apricot or information and pineapple, I mean, the similarity is almost zero. Okay. So this is the notion behind the word-to-vec model, which was introduced in 2013 by Google, which saw this rise of like deep learning techniques in natural language processing. So which allowed the idea of representing words as a vectors, not just a vector, because you know that in the previous slide, these vectors are very, very long. Like if your vocabulary size is 1 million, then each vector is 1 million. I mean, its dimension is 1 million. But there is a clever idea used in word-to-vec model using the SVT techniques, which give it the ability of like making it low dimension vector. Okay, so typically, I mean, word-to-vec models provides a vector size of 50, 100, 200, 500, something like this. Okay. And it uses a shallow neural network with a single hidden layer. And there are two different approaches. One is called the continuous backup words, and the other one is skipgram. Very similar approaches, just the opposite approach. Okay. And typically, it is I mean, Google basically trained it on the entire web corpus, which they were able to crawl during that particular time. So the entire web corpus, I mean, it's basically was for English. So the entire web corpus is in English, and they showed in that paper for the first time that this word-to-vec model is also able to make this kind of like equations. Like if you take the vector of king, if you subtract the vector of man plus, and if you add the vector of woman, you will get a vector which has almost same vector as queen. Okay, so these are like those like logical tasks that you have in aptitude tests in different examinations. Okay, king minus man plus woman is what? Okay, so these tests your vocabulary. Okay, and word-to-vec was first time able to do this using the distributional semantics model. And if you also see that, I mean, the relation between man and woman, or king to queen, is they are parallel. Okay, similarly, man to king, the relation between man to king and woman to queen, they also look parallel. Okay, so I mean, if you take the names of the countries and if you take their like the capitals, these relations between them, they look some almost parallel. Okay, some more tasks in NLP. Named entity recognition, I already told about it. Anaphora and Kura reference resolution, I already mentioned this. Textual entailment is the task of like giving a piece of text, like let's say, so you'll be given a pair of text. Okay, the one is called the text, the other one is called the hypothesis. Okay, let's say the text is person ABC was murdered in this particular place on this particular date during this particular time and so on. Okay, this is the text. Text is typically a long text, and the hypothesis is person ABC is dead. Okay, so you will have to make decision about whether the truthness of the text decides the truthness of the hypothesis. So in this particular case, if the text is true, if the T is true, then the hypothesis must be true. If a person has been murdered, then that person is not alive anymore. He is dead. He or she is dead. Okay. So this is what textual entailment means. These days, it is referred to as natural language induction in a task. Paraphrasing basically referring to, I mean, so you can express the same thing, exact same meaning by two different ways. Okay. So paraphrasing something. So given a pair of text, whether you'll have to say whether they are paraphrases of each other. That is paraphrase detection or identification, or paraphrase generation. Given a sentence, you'll have to generate another sentence which conveys the exact same meaning but written in a different way. Okay. Entity disambiguation. I have an example of that, and I will tell you. Okay. So in here, so the task is find and classify names in text. Okay. So for example, in this particular text, you will first identify that these are the proper names that are mentioned in this text. Okay, but remember, this is not easy for Indian languages or other Indian like languages. It is somewhat easy for English. Then it will classify the proper names into the classes. It will say that this blue ones are the persons, this green one are the dates, the location. There is no location here, and the these brown ones are the organizations. Okay, this is NER. This is the task of NER. I'm not going into these things. Okay, then entity resolution. Sometimes you may have different things by the same name. Okay, say, I mean, you have in every city in India, almost in every city, or at least in the big metropolis, there is at least a road by the name Mahatma Gandhi Road. Okay. Similarly, there could be multiple persons by the same name. These are all famous persons who are named Kevin Smith. Okay. So you have in here which have identified that this is Kevin Smith, and I mean this is a named entity and this is a person. Okay, but that is not enough. You'll have to identify which exact Kevin person this particular sentence is talking about. Okay, so in some tasks, linking to knowledge is very important. Okay, say for example, your knowledge is limited; it should grow day by day. Okay, so you have built a knowledge extraction system which can automatically extract knowledge from newspapers or papers or whatever news, and then can add additional information that are coming at new to the knowledge graph or the knowledge base. Okay, if that is the case, then for this particular sentence, it has to know which, because if I go to Kevin Smith, you will see. Okay, let me go to the Kevin Smith page in Wikipedia. It is talking about disambiguation, Kevin Smith disambiguation. See, these are all the persons that are famous. They have a Wikipedia page, means they are famous. All of them are famous. Okay. So you will have to identify which exact person it is talking about. Even if you see, I will just show you. I saw somewhere like there are multiple persons by the same name who has the same identity. So, for example, Kevin play. I saw some other case like there could be two footballers by the same name. Okay, so they are both very famous. They both have Wikipedia pages and they both have information in the knowledge graph. So again, you'll have to identify between them which exact person I'm talking about. And then again, once you have done that, once you have disambiguated the entity, then you can link it with the knowledge graph or the knowledge base. Okay. Textual entitlement, I think I already gave some example. This is the scenario in NLP. Like when I was doing PhD I submitted my PhD in 2008. So when I was doing PhD, there were only a few players like Google and Microsoft. Even Google was very new then. Okay, Microsoft and Yahoo and Xerox and I think Oracle used to do some NLP and IBM. Okay, typically there were very few research labs that were doing NLP, like IBM Research Lab, Microsoft Research Lab, Yahoo Research Lab, and Xerox Research Lab. These were the four renowned research labs that were doing NLP. But you know that in the last decade, almost every other tech companies they are doing NLP. Okay, so and there are so many new players, big players in NLP. The companies like Facebook, Apple, all the big corporations in softwares or in computers, they are doing NLP. This is information extraction. Okay, this is just a typical case. Like say, for example, you want to extract information from mail. So this is a mail from Christopher Martin to Daniel Jurafowski, who wrote. I mean, they are the authors of the book on language and speech processing, which is the most followed book in natural language processing. They are both professors at Stanford University. Okay, so it says, hi Dan, we have new scheduled this curriculum meeting. It will be in GATS 159 tomorrow from 10 to 11:30. So here the task is whether, so this meeting is talking about a curriculum meeting, which is an event which is going to happen in GATS 159, which is the hall or meeting room, which is going to happen on January 16th, because the mail is written on January 15th and it talks about tomorrow. Okay, and the time is 10 to 11:30. Okay, so these are the pieces of information about the event. Okay, so can you build a system or software which can automatically extract this piece of structured information about the event, and then it can automatically populate uh, in your calendar? Okay, I don't know why Google has not done this. It is not so difficult to do this. At least for big company like Google, they are very good at NLP, and they have very big teams. So it is not so difficult for them. But if it was the case, then it would have been very easy for you to maintain your calendar. Okay, you do not have to populate your events manually. You can do it on your own. Sentiment analysis, let's say you have decided to buy a camera. Okay, so these days what you do is, once you have decided that you will buy a camera in a particular type of camera, then you have selected a few models, then you want to know which exact model you should go for. So you go to internet, you search about this particular model, and you see what people are saying about this particular models. Let's say 5 models. Okay, you have narrowed it down to five models, and then you want to then you have to finalize. Okay, so before that, you are reading reviews of the users, like what people are saying about this particular cameras. Okay, so first of all, you have to identify the what are the important aspects or the attributes that comes when it comes to doing sentiment analysis, or for cameras. Okay, so these are called aspects of the attributes. This thing is called aspect analysis. Okay, so when it comes to buying a camera, zoom, affordability, size and weight, flash and ease of use, these are the important points that the users are saying about. Okay, now, so let's say for the size and weight, this particular nice and compact to carry, this looks like a positive response from the user. Second one also looks quite positive. Third one, the camera efficiency is plastic. These are not good things about the size and weight. Okay, these are negative comments. So these part is the sentiment analysis, classifying each piece of sentence or text to either positive or negative or neutral. Okay. Then if you will take aggregation of this, then it will look something like this. Okay, and this becomes very useful for both the user as well as the service provider or the company. So from this, the user knows that, if the user needs flash, say the user loves night photography, maybe video photography or whatever, night photography, then flash is a must. Then this is the camera he or she should go for. Okay, but if the user is very concerned about the ease of use, then this is not the camera he should buy. Okay, because this camera is very difficult to handle. Okay, so even it is important for the companies as to know what the users are saying about their products. Okay, so as a company, so this is about a particular Nokia camera, and I'm from the Nokia top executive team. Okay, so I should worry about. I mean, when I come up with the next version of this particular camera, I should improve the user experience or the ease of use for this particular camera, because the users are not happy about the ease of use with this particular model. Okay. Some advanced topics in sentiment analysis, aspects analysis, I already said, because nothing is black and white. Like, say, take this example. So the food was great, but the service was pathetic. You can neither assign positive sentiment nor negative sentiment through this entire sentence. Okay, the user was partly positive and partly negative. Okay, so you'll have to identify what the user is positive about and the negative about. So these are the targets of the aspects. So the user was he liked the food, but he did not like the service. Okay, it is also identified to. It is also important to identify the subject or the holders of the sentiment. Let's say this particular sentence: I thought the food was good, but my friend felt otherwise. So here I like the food. Okay, so I'm positive about the food. But my friend who went there with me to the restaurant, he did not like the food. Okay, so it is also identified to. It is important to identify the subjects. Sarcasm and irony detection is a difficult task in sentiment analysis, because both in sarcasm and irony, apparently what looks is actually what it is not. Okay, but to identify whether it is actually meant or it is the user is being sarcastic or ironic is difficult. Okay, these days you will have, because you have a lot of social media data and you will have to deal with it. You cannot just build classical models that only takes classical text. Okay? So you'll have to deal with noisy data. And these days with the social media, particularly when you are like chatting in some chat application or in WhatsApp, typically most of the users are like they are more familiar with the English keyboard than with the native keyboard, like the Bengali keyboard or the Hindi keyboard. Like say for example, I never use Bengali keyboard in my mobile. I mean, it takes so much time, and I feel like it is a pain to me. Okay, so I write everything in English. Even when I'm writing something in English or in Bengali, I'm writing it using the English keyboard. Okay. So, and moreover, you'll have to deal with this phenomenon of code switching and code mixing, because when you speak, typically not, I mean, when you're speaking with friends or students, we mix a lot of words from different languages, particularly Bengali English, Hindi English, sometimes Bengali Hindi. Okay. So from the, let's say, I say the sentence, Kal University Bando ache due to কি যেন ছট পুজো। I write this everything. I basically said a Bengali sentence, but there are many English words used in this particular sentence. Okay, so let's say this. So due to short. Okay, I don't know what's the principle. So here the system has to identify that this call bondo ache ache. Okay, these words are Bengali words, whereas this university, due to short, can be considered maybe in Bengali, belonging to both Bengali or English. Okay, it does not really matter. But otherwise, for the other words, you'll have to identify in which particular language it belongs to. So it's not like even if I'm speaking in Bengali, I'm saying all the words in Bengali, because we always mix words from different languages. Okay, so this is the challenge. Now let's consider this particular sentence. Let's say in this particular sentence you're dealing with text. Okay, so you have seen this word PORE. Okay, now you'll have to take a decision what this particular word mean. Okay, first of all, if this word is in English, if it detects that it is in English, then its interpretation. Okay, but what if the word is Bengali? If the word is Bengali, it can have multiple transliterations. We call this transliteration. Okay, what is transliteration? Transliteration is the uh, this, like, given a word in a particular language in English, you will have to phonetically translate it. Okay, so you will not. I mean, when you talk about translation, we do not translate it phonetically, but names are not translated, right? So that is why we use phonetic translation. So these has to be then okay, yeah, this has to be. I mean, if a word is identified as Bengali, it has to be transliterated. Okay. Now there are multiple options. It could be pore or pore or pore or pore. Okay. If the word is pore, then it can also have many different interpretation. Pore means later. It could be later, adverb, or after, or like particular trace pore, wearing something. Okay. So you have so many different interpretations for this particular English word. Now, what if I made a mistake during the typing? Maybe the word was that I originally wanted to type is PORT or maybe BORE. Okay, but I mistakenly typed PORE, because typically when we uh, type for chatting, I mean, we do very fast typing and we do a lot of mistakes and we do not really care. Okay. So then again, if the word is port or bore, the system has to make all these decisions. What is the exact word, which in which this particular language the word is in, and what is the exact interpretation of that particular word in this particular sentence. Okay, so you can see the complexity of this language. Even you will have to take the decision of whether you should employ language identification first or text normalization first. Okay, even if you are not sure about the pipeline. Okay. Maybe maybe I've taken a lot of time, so I will try to wind up. I will just summarization. Summarization can be of three different types, depending on the input. What you want to summarize, it could be single document summarization or multiple document summarization. Okay, if I say my student, I do not know this particular topic, write something on this particular topic, and then summarize it to me. Okay, so then what the student will do is that he will refer to multiple sources and then come up with his own conclusions and summary. Okay, so that is multi-document summarization. Given multiple documents on the same topic, you'll have to produce a summary. Okay, type of summary, it could be generic summarization or it could be query-focused summarization. Query-focused summarization is something like, let's say, for example, what is the viewpoint of Kejriwal on NRC? Okay, because for a long time, even I think till now, he's not very clear about NRC, his stand about NRC. Okay, so here I am asking for a summary, but here I have a very specific query. Okay, my specific query is what is Kejriwal's view on the NRC issue? Okay, that's the exact query, and it is more like a question answering system, but essentially you are producing a summary, the summary of the answer. Okay, and then type of summarization, depending on the approach, it could be extractive or abstractive. Extractive summarization is like very old technique. Here, typically what you do is given a document, you segment the text into sentences, and then based on there are many different features. Based on those features, you compute the relevance of the sentences with respect to this document. So you kind of produce a ranked list of the sentences, okay? And then if your task is to produce a summary within 100 words, then you will pick top in sentences that fit your 100-word length prescription, okay? But abstractive summarization is very, very easy. This is not even a student project. It is like an assignment, okay? Abstractive summarization is like human summarization, and it is difficult because generating natural language is very difficult task. Okay, uh, before this LLM things came into being, like before 2018, 2019, till then NLG was a very big deal. Generating anything which is a textual content was a big challenge. Okay. But these days, generation is almost not. It has become very easy if you are using LLMs. But that is the task. Uh, uh, abstract generation is given a text. You'll have to produce. You'll have to, just like you're producing a human-like summary. Okay, so you'll have to come up with your own words, own idea about the event, whatever it is talking about. Okay. Knowledge extraction. I think I will add. So knowledge extraction is given this document, say you have a large corpus, or say Wikipedia, or say, I don't know, some other very reliable sources. And from there, you want to extract knowledge, okay, which are in this triplet form, E1, E2, and the relation between them, okay. So this is typically how it is done. So John was born in Liverpool and to Julia Alfred Lennon. Say this is, you have found this in a text. So what you have to come up with is John Lennon is a person in Wikipedia or maybe in WikiDB. Okay, it is a node. So this John is referring to John Lennon. He was born in Liverpool and he's a child of Alfred Lennon and Julia Lennon. Okay. Now there are many challenges. First of all, you'll have to do part of speech tagging. You'll have to do dependency parsing. This is a dependency parsing. Okay. You'll have to do NER, named entity recognition. You'll also have to do named entity resolution or the disambiguation. Okay, and then you'll have to do named entity linking. Okay, in fact, knowing that this John is referring to John Lennon is a big deal. Okay, how do you know that? Okay, even I was searching with Liverpool and I found that there are 12 cities in the world by the name Liverpool, which are all of them are popular cities. Like they're not small towns. Okay, they are like big cities. Okay. In fact, in UK itself, there are multiple cities by the name Liverpool. So how do you know which exact Liverpool you should link it to? Okay, that is the task. In fact, you will notice it once that after doing this task, so this is called the task of graph completion. Here you have this graph, okay, and after doing the graph completion task, I have added some other nodes, which is spouse relation. So I have said that Alfred Lennon is a spouse of Julia Lennon, and Julia Lennon is a spouse of Alfred Lennon. Now, this thing is not explicitly mentioned in the text, okay, but this kind of knowledge can also be extracted if you are doing some sophisticated knowledge extraction. Okay, this is like the intuitions that we make as humans. Okay, so this task is called graph completion. Given a graph, knowledge graph, you'll have to assign additional edges or relations within the graph so that you can make the graph more complete. Okay. Uh, Event extraction. I mean, I will just give this like example. I do not have the time to go all this.
Hello?
Yes. Should I finish now?
Yes, sir.
Okay, okay. So yeah, maybe I had just a few more slides, but maybe we have discussed enough and we can take any questions if you have any. Otherwise,
Okay. Yeah, may I ask the question from the
yes,
participant?
yes, please.
Okay. One question is there, sir. So, would you kindly explain how does NLP helps in translation sites?
In what sense?
Would you kindly explain how does NLP help in translation studies?
Well, translation studies, I don't know what background you have. Translation studies is typically, I mean, this is a course which is taught in humanities, like in typically, I mean, we in Jadavpur University, we have it Center for Translation Studies. So this is a skill for teaching how translation is typically done. But in translation studies as well, when I was doing postdoc in Ireland, we had a very big group. I mean, we were in the computer science department, but there was a school of, I don't know, I forgot the name of the school. School of CELIS, School of Applied Linguistics and something. Okay, but they had a very good translation studies group. So we are working in very close collaboration with them. So when you are doing translation, first of all, your machine translation system should be like it should be useful and effective to the translators. Okay, but then again, we were doing many gauge-based system. Like what are the like when a particular translator is using a particular translation software, what are the different types of edits he or she is making? Where are he or she is looking at which particular words in the source or in the target? What are his like time durations on the particular words or uh, frequencies of the time gauges and so on, many different studies. And then based on this, we can take this input from the translation studies, okay, and take these things into the translation model. So if I have those kind of inputs, then I can additionally enrich my model that I should look into these. I mean, so it is like, let's say a translator is translating, okay, without the help of animation translation system. Now, when he's translating, he is looking at the source words in a particular sequence, in a particular fashion. Okay, so where are his attention during the translation process? So we can take that kind of information from the translation studies and employ those kind of information in the translation process itself. Okay, so this is, I mean, translation studies and machine translation have a very what should I say? I mean, uh, they should collaborate very highly. And in fact, any machine translation group, if that particular institute has a translation studies group, they often have very strong collaboration. Any more questions?
No, sir. There are no questions, sir. There. Only
Okay.
one.
Okay, so thank you very much for giving me this opportunity. I hope the um, lecture was useful, somewhat useful to you, and you had a pretty broad idea about the different tasks and the challenges and the applications of natural language processing. So that's it from my side.
Thank you, sir, for giving us your valuable time and delivered this wonderful session. And I hope we will meet again soon, sir, and we will get another interactive session. Thank you.
Thank you very much. Thank you, everyone.
Thank you.
Bye.